Now, gravity probe B is going to measure that warping of space to higher precision than this landmark experiment, at least a factor of 10 higher, perhaps more. And we can understand how gravity probe B does that in the language of the missing inch that Francis Everett described. So here is the plane of the orbit going around the Earth, which is down at the center. And if the orbital plane were absolutely flat, like this sheet of paper, then the gyroscope would point always in the same direction as it goes around and comes back to where it started, around and around, always pointing toward the guide star up here. But in fact, there's the missing inch. And so we can remove that missing inch by cutting this sheet down those lines and pasting it together to form a cone. That cone is actually tangent to the warped surface, the bowl-like surface that I showed you in the graphic. So here is that cone, and it's pretty easy to see what's going to happen on that cone. On that cone, and you see it is a cone. You start out with the gyro with the gyro pointing in this direction, and you carry it around. This is identically the same set of arrows as on the previous diagram. And you come back, and it has turned. It's turned because of the missing inch. So you can do that yourself. You can just draw this sheet on here, and then cut out the cone, paste it together, and you see the turning of the gyroscope. So that is that's the principal cause of the so-called geodetic precession.